Hello and welcome back. Today, I'm going to be going over the assignment that we had for 1.6, which was transformations. I'm not going to do every problem because this was your assignment. This is just like, okay, if you struggled with the problem, hopefully I'm doing the one that you struggled with. But it gives you a little bit of a review as well. So, some from the beginning. I'm probably only going to get one, maybe two done from here because there's not a lot of room to do it. So, let's do number let's just do number 1. Y equals x squared would be a parabola. And if we shifted it 4 units up, well, it would be a parabola that is 1, 2, 3, 4 up. Ta-dow. The official answer I'm going to be having here in black. That would be g of x. And let's look at, I don't know, I guess we'll look at number 4. Y equals, number 4, in red for starters, would be y equals x is a line. And then if we translated that line 2 units up, it would be 1, 2. Done. It's not asking you to write the equations, so those would have been very quick for you, I would hope, provided you remembered what the basic graph of a parabola versus a line looks like. Then we're going to do a few from down here. Use the graph of each translated parent function. Identify h and k and write its equation. So f of x is the original. And if we had, let's do 8. We haven't done any that move to the left. Here in blue, I think that's blue, we have f of x is the absolute value of x. And then it moved, for g of x, it moved to the left by 1, 2, 3. That point is at -3, 0. So if we change the sign, keep the sign, it would be x plus 3 in absolute value bars plus 0. So the h and the k are the vertex. H is -3 and k is 0. Ta-da! And let's keep the absolute value trend going. We got number 10 right here, and that one has a double shift. It moved to the left, right 1 and down 2. So f of x may have been the absolute value of x, but g of x went, and this point is 1, -2. So if we had to change the sign and then keep the sign, it would have to be change -1, keep -2. And your vertex, as always, would be change keeped as well from the equation to get your h and your k, which would be +1, -2 for h and k, respectively. All right, moving right along. Those are really similar to the notes. Let's see, example 3, there's 2 of those, so why not do 1? F of x is compressed horizontally by a factor of 2. So if we have that, we got y equals x squared, looks like this. If we compress it horizontally, that would mean that the new graph would be a little bit fatter and reflect over the y-axis. Reflecting over the y-axis, again, doesn't do anything because it's already symmetrical. Now, it doesn't do anything in any of the situations we've had, but there are situations where it could kind of flip over. But in this case, it was already symmetrical, so we didn't. If it reflected over the x-axis, that would have flipped it over and would have done like that number, but this one wasn't. All right, let's do one from down here. Describe each dilation. Let's describe number 16 and 18. Well, oh man, a lot of them are funky. So 16, it is stretched horizontally by 2 because it's a 1/2. A 1/2 implies stretched horizontally. By 2, it is flipped or reflected over the x-axis because the negative. Now as number 18, I'm not going to fully do that one. If you were to distribute the thing here, it looks like it's flipped over the x-axis, but it's actually not. If you just square the 3 and square the 4, you'd end up with 9 over 16 positive x squared. So it would be stretched, but it wouldn't be flipped. Here, the absolute value of x for number 17, going all sorts of out of order, because the negative is in front of the absolute value bar, if you were to graph it, it would still be facing up. So that's just a stretched horizontally because it's a fraction by 3, or you could say 1/3. I wouldn't be too upset if I was your teacher. But it's stretched horizontally with a factor of 3. The scale factor in general for that problem would be 1/3. But the stretched aspect is it's stretched horizontally by a factor of 3. It is compressed vertically by a 1/3 factor. It's a wording thing. All right. Let's see how the word problems did. I bet they're not that bad. Let's pick one. 23 has 2 things going on, so I'm going to pick that one. The cost of traveling X miles east or west on a train is the same. The function for the cost is here. Describe how c of x is related to its parent function and interpret in context. So here we've shifted it up by 25, so it's going up by 25. And it is compressed horizontally. It's stretched horizontally. Because the 0.75. It is less than 1, therefore it is being shrunk down. Okay? So that means that they're charging more. They're charging a base price of $25. I'm not going to have enough room to write this. Charging a base price of $25. They're increasing their prices by $25, but they're charging less per mile now. A little bit less than they were charging per mile as before. So they're getting a lot and encouraging you to take maybe longer trips. All right. Let's do number 25. 25 got moved up by 1, 2, 3, 4, 5, and to the left by 2. This point is -2, 5. Therefore, our absolute value of that, I'm leaving a blank for my scale factor, would be change the sign, keep the sign. Now, what number do I need to put in here? Well, the slope of this absolute value is up by 2 and over by 1, which means that it is stretched vertically by a factor of 2. Okay? One more page, probably a few more minutes. All right. Let's look at 29. 29 looks exciting. It got reflected over the x-axis. So that means that it is something involving the original function for g of x. G of x is going to be a negative in front because it's flipped over. And it also, this point is at 4, 0. So I would have to change the sign and keep the sign. But it's not an absolute value. So that means that it needs to be a parabola with a squared. The original f of x was a parabola, so it's squared. Not a v, so it's not an absolute value, but it operates the same way. You just use parentheses and a squared. So here, we also have to find h and k and or a. A is the value in front, which would be -1 for a. So that's new. A is the value in front, in case you're wondering. That's the scale factor. H and K, 4, 0, change the sign, keep the sign, are 4 and 0. And then the A is -1. Let's do one more from this bottom chunk. Maybe 34 and one of these up here. So here we got identify the effect of adding 3 to every x value. So if we were adding 3 to every x value, where do you think that 3 would go? Any ideas? Well, here's x. Let's put a +3 there. I don't know what they're even asking for. Okay. It would move to the left or right by 3 if you added it. If we wanted to go and add 3 to the x, we should have changed the sign, we would want to go to the right by 3. And if we want to go to the right by 3, we would have to put, for part B, which I already did, it would need to be a y equals negative x minus 3 with the absolute value. In consideration with that, consider number 32. Identify the effect of adding negative 2 to the y values. That would move it down by 2, right? Because y is up and down and x is left and right. And then it says graph the transformation. Oh, well, if we went down by 2, it would look like that. Okay? Moving right along with 34, identify the effect of multiplying the y value by 3. Well, if we multiplied the y value by 3, that's not that bad. We would just multiply the y value quite literally by 3. So I'm taking 9 and multiplying by 3, and 4 and multiplying by 3, and 1 and multiplying by 3, and 0 and multiplying by 3. I'm just multiplying by 3. And the x values did not get multiplied by 3, correct? So the x values remain the same. All right, ladies and gentlemen. So that's it for this one. Remember, all the assignment ones are a little short. My name is Bradley Sohn, teacher here at Beachside. I hope everybody's doing okay. Stay positive. Everything will all work out. I will see y'all later. Bye.